we have already learned that the principal quantum number tells us the main energy level of an electron. But to understand the exact location and shape of electron cloud or shape of orbitals, we need another quantum number that is called Azimuthal Quantum Number. Okay? Hi everyone, welcome to Chemistry Portal. I am Sudhanshu Kumar and today we are going to talk about Azimuthal Quantum Number. So first point, Azimuthal Quantum Number. Azimuthal Quantum Number. And this quantum number denoted by a small l. Okay? Now, the first point is Azimuthal quantum number. It is denoted by a small l. Now, the second point. This Azimuthal quantum number was first proposed by Arnold Sommerfeld. Okay? So write it here, proposed by Arnold Sommerfeld, scientist. And this quantum number, this Azimuthal quantum number, it defines the subshell. Okay? It defines the subshell. So write it here. It define, or you can write it here in the next point. This L value, this quantum number L, it define the subshell. Because in the earlier videos I talked about atom, cell, subshell, atomic, orbital, electron, right or not? Okay? So you can check in the playlist. Okay? I will give the link in the description box. You can go through it. Right? Okay. So we have 3 points till now. Azimuthal quantum number, it is denoted by a small l. Okay. Now it is proposed by Arnold Sommerfeld. Okay. And after that, from Schrodinger equation also, we get the solution as a L. Understood? First of all, this Azimuthal quantum number L, it is proposed by Arnold Sommerfeld. But when Schrodinger came, and if you solve that equation, Schrodinger equation, you will get this L value as a solution of that Schrodinger equation. Because in the first video, I told you that this 3 quantum number, principal quantum number, Azimuthal quantum number, and magnetic quantum number, all 3 quantum number, these are the solutions of this Schrodinger equation. If you solve the Schrodinger equation, then you will get these are the solutions of that equation. Okay? Right? But the first term, subshell is used by Arnold Sommerfeld. Okay? Right. Now. So, it was proposed by Arnold Sommerfeld, and Azimuthal quantum number, it defines the subshell. Now, how to find the L value? Right or not? How to find the L value? So, L value actually belongs only integer value. Okay? Only integer value. from 0 to n minus 1. So write it here. Sorry. So this L value, L belongs only integer values from 0 to n minus 1. 0 to n minus 1. Clear everyone? 0 to n minus 1. And this n is what? This n. This n is called principal quantum number. Already we have discussed, okay? You can check in the lecture number 6. This is the lecture number 7. Okay? So this n is called, this small n is called principal quantum number. Principal quantum number. Now, so how to find the L value? Sorry. So this L value belongs only integer value from 0 to n minus 1. Okay. Now, if you see carefully here, this L value coming only integer value from 0 to n minus 1, and here this principal quantum number is coming here, right? It means what? It means this L value depends on n value. Okay? So write it here. This L value depends on n. Okay? N is what? Principal quantum number. Okay? One more thing. I told you that this L value belongs only integer value, right? It means this L value is what? This small l, it is quantized. Okay? You can write it in point form. This L is what? Quantized. This L is quantized. Okay? Quantized means what? Quantized means it can take only a specific discrete value. Okay? It means this L can take only a specific discrete value. So right here means it can take L can take only a specific discrete value. Okay? Now we will discuss very important. Okay? So right here value of L, and here write a subshell. So if you have L value 0, it is called S subshell. If you have L value 1, it is called P subshell. If you have L value 2, it is called D subshell. If you have L value 3, it is called F subshell, and so on. 4 for G, G subshell, H subshell, and all alphabets. Okay? Right. But the question is, what is S, P, D, F, and how this symbol came? S, P, D, F. Right or not? So this S means right here note. Okay, note. This S came from, you can write it here. This S means sharp. Okay. P means principal, right? And D means diffused. F means fundamental. G means generalize. So these are the full form of S sharp. P means principal, D means diffuse, F means fundamental, G means generalize. And this all name came from a spectroscopic study. Okay, understood? We will not go in now a spectroscopic study because this is the course of Introduction to Organic Chemistry, right? I am just giving you overview, brief introduction of all the quantum number, right? Okay, now, so all this value came from where? Came from, write it here. These names came from a spectroscopy, comes from a spectroscopic study. Okay, so this is very important. Okay, this part, this table. L value 0 means it is a S subcell. L value 1, it means it is a P subcell. L value 2, it means it is a D subcell. L value 3, it means it is a F subcell. Clear, everyone? Okay, now write the last point, and that is a very, very important point. Last point, it is L value can determine, so you can write it here, L can determine three-dimensional shape of orbital and energy of orbital and angular momentum of orbital. Okay? These all things L can tell us. Okay? By the help of L, we can tell the shape of orbital, we can tell the energy of orbital, we can compare the energy of orbital, and we can tell the angular momentum of an orbital. Clear, everyone? Okay, now, so write it here. L determines three-dimensional shape, shape and energy also, and orbital and angular momentum of an orbital. Energy and angular momentum of an orbital. Very, very important. L can determine the three-dimensional shape and energy also and angular momentum also, right, of an orbital. Clear, everyone? Okay. So basically, now revise the points here. Azimuthal quantum number. First of all, a small l, it is a symbol, right? And it was proposed by first Arnold Sommerfeld, okay? And this L value defines the subcell, right? And this L value belongs only integer value from 0 to n minus 1. And this n is what? This n is called principal quantum number, okay? And now, it means L value depends on n also, okay? Clear, everyone? Okay. Now, and because L value can take only integer value, it means L is what? Quantized. Means it can take only a specific discrete value. And now we come to the value of L. If you have L equal to 0, it means it is a S subcell. If you have L equal to 1, it is called P subcell. If you have L equal to 3, it is called F subcell. So 0 for S, 1 for P, 2 for D, and 3 for F. Clear? So if I give the value of L, you can tell me that which subcell it is. Okay? Understood? Right. Now, and this all S, P, D and F name came from where? S means sharp, P means principal, D means diffused, F means fundamental, G means generalized, and all this name came from spectroscopic studies of the atomic spectra that we will not discuss now here. Okay, that is a totally different course that we will discuss in the especially in the atomic spectra and all the things. Okay, now suppose if I one last point, and this L value we can determine by seeing the L value. First of all, three-dimensional shape and energy and angular momentum of an orbital. Okay, we can determine the shape of the orbital. We can determine the energy of the orbital. We can determine the angular momentum of the orbital. Okay, so these are the some features of L, azimuthal quantum number, right? And do one question, very simple question I will give you. Okay, for n equal to 3, for n equal to 3, suppose for n equal to 3, how many subcell possible? How many subcell possible? So very simple, right or not? I told you how to find the L value. How to find the L value? See here. L value belongs to 0 to n minus 1. Now, L equal to what? 0 to n minus 1. Right or not? So 0 to, here in the question, n equal to 3. So put it here, 3 minus 1. 3 minus 1. So we'll get what? 0 to 2. So 0 to 2, between 0 to 2, how many you have integer value? So that is 0, 1 and 2. Right or not? These are only integer value possible. These are only possible L value for n equal to 3. Right? And now we know that 0 means what? This L equal to what? 0, 1, 2. So it means 0 means what? S subcell. 1 means what? P subcell. 2 means what? D subcell. Right? So we can say that in the n equal to 3 cell, we have 3 subcell, and that is S, P and D. This is your answer. Clear everyone? Okay, how I did this? It's a very easy, super easy. Okay, for n equal to 3, how many subcell possible? Apply the formula. L equal to 0 to n minus 1, right or not? And here the n value how much? 3 here. So 0 to 3 minus 1, how much it is? 0 to 2. And we know that L value only belongs to what? Integer value. L value belongs only integer value. So now you tell me, between 0 and 2, how many we have integer? One is 0, one is 1, and one is 2. So we have 3 integer value possible between 0 to 2, and that is 0 means S subcell, 1 means P subcell, and 2 means D subcell. Right? Okay? Okay. So, and in the next lecture, we will talk about the shape of the orbital. Okay? Shape of the orbital. Right? If you found this video helpful, please like, share and subscribe the chemistry portal, and let me know your questions in the comment box if you have. And thank you everyone. Thanks again.